All right, am I recording? Okay, so today I'm going to talk about elements and compounds. It's going to be a bit of a review of what we've already gone over and then starting our discussion on inorganic compounds, which will start next week, which involves water. So today we'll kind of talk a little bit about hydrogen and oxygen and their significance in forming or breaking down chemical compounds. So all of the naturally occurring elements in our entire universe are divided into two primary categories, the first being metal elements and the second being non-metal elements. Now, if you look at a periodic table, there's actually three categories in between metal and non-metal, and they're called metalloid, which means they have the characteristics of both metal and non-metal, but they don't quite fit into each of those categories. But for our discussion right now, we're going to say there's two main categories, metal and non-metal. Metal elements typically have these characteristics or properties, and I say most because, as we know in science, there are always exceptions to a rule. But for the most part, metal elements have luster, which means they have a shiny surface or they have a quality of reflecting light. Metal elements also have ductility, which means that they can be formed into thin wires. So think of like copper and copper wiring. Metal elements are also malleable. They have malleability, which allows the element to be formed into thin sheets. Metals are good conductors of heat and electricity, and metal elements mostly appear in solid state at room temperature and pressure. They have a positive electrical charge. Non-metal elements, on the other hand, they're not shiny, they do not possess luster, they're non-ductile, non-malleable, they're poor conductors of heat and electricity. They can appear in all states of matter at room temperature, gas, solid, or liquid, and they are negatively electrically charged. Here is the periodic table, and as you can see in this like silver bluish color, those are your metal elements. And it's kind of grayed out, but the more copper colored, those represent the non-metal elements, and then the metalloids are those green right there. Let me see, I think I had a note about metalloids. Yes, metalloids are elements with properties in the middle of those that are metal and non-metal. For example, silicon, which is the atomic number 14, Si. Silicon is a metalloid because it has luster, but it's brittle, so it can't quite fit into both of those, into either of those categories. So then we have the noble gas elements, which are also known as the rare gases or the inert gas elements. And they are a unique group of non-metal elements. All of these elements appear in the gaseous state at room temperature. They have no electrical charge and are not easily combined with other substances to form compounds. Noble gas elements are that last vertical column of the periodic table. So column 18, helium, neon, argon, krypton, xenon, and radon. Those are your noble gases. Then we're going to talk briefly about a couple of chosen elements, the first being hydrogen. Hydrogen has the atomic number 1. It's the first element of the periodic table. It appears in a gaseous state at room temperature and normal pressure. Hydrogen atoms contain 1 proton and 1 electron. It's considered to be the smallest, lightest, and simplest element known to man. Hydrogen is the most abundant element in the universe and is a constituent, meaning it's involved in a lot of reactions of inorganic compounds such as water, acid compounds, basic compounds, and salt compounds. hydrogen actually means water former. And when isolated from other substances, hydrogen exists as a pair of hydrogen atoms linked by a covalent bond. Hydrogen is a positively charged element. Pure molecular hydrogen is colorless, odorless, and tasteless. Hydrogen will burn, but it will not support combustion of other substances. So that's that property of being a nonmetal. And pure hydrogen gas can be prepared by the electrolysis of water, the decomposition of an acid compound by a metal substance, and by decomposition of water by a metal substance. Talking about this decomposition. And then hydrogen is also selected to act as a reducing agent in a chemical reaction. So there's two different types of agents that we'll talk about. One is reducing and the other is oxidizing. So hydrogen is involved in reduction, which could be the removal of oxygen from a substance or the addition of hydrogen to a substance. Reductions also, it results in a decrease in the number of valence electrons in an atom during a chemical reaction. But reduction also causes the gaining of electrons during a chemical reaction. So remember, there's two things reacting. And the acronym to remember reduction is RIG, R-I-G. Reduction is the gaining of electrons. That's how you can remember that. Then we have oxygen. Oxygen, whereas water means, whereas hydrogen meant water former, oxygen is an acid former. And when oxygen is combined with certain inorganic elements, acid compounds are formed. Oxygen is the most abundant element on Earth. So hydrogen was the most abundant element in the universe. Oxygen is the most abundant on Earth. And it occurs naturally as molecular oxygen, which is a diatomic molecule, O2, meaning those two atoms are working together as one molecule. Okay, a single oxygen atom is called nascent oxygen, and 3 oxygen atoms united chemically is called ozone, or O3. Pure oxygen is a colorless, odorless, tasteless gas at room temperature, and it's a natural component of air. Oxygen supports the combustion of other substances, but does not burn itself. Pure oxygen can be obtained by, so oxygen, pure oxygen doesn't necessarily naturally occur. It naturally occurs as molecular oxygen, which is O2. So in order to get pure oxygen, that nascent oxygen, it has to be obtained by the electrolysis of water or the decomposition of an oxide compound. Remember, an oxide is oxygen combined with another substance. And the fractionalization of air. Those are all chemical reactions. So we talked about reduction, which involves hydrogen. Now we'll talk about oxidation. So oxidation is when a compound occurs that contains oxygen and another element, and they're called oxides. Oxides act as oxidizing agents in chemical reactions with other substances, and there's 5 different types of oxidation. There's slow oxidation, which is exactly what it sounds like. It's slow. It occurs at low temperatures. An example of this would be, an example of this would be the rusting of metal. Another type is rapid oxidation. It happens very fast at high temperatures, and it's also known as combustion. We also have spontaneous combustion, which is when there's an accumulation of heat produced by the slow oxidation, but it's unvented. So it can occur as an explosion, a spontaneous explosion. And an example of this that I found was the spontaneous combustion of grain silos. If they aren't vented properly, they could just explode spontaneously, which I found was interesting. But that's that unvented accumulation of heat. There's so much pressure that can happen before an explosion happens. Another form of oxidation is decay, which is slow oxidation of organic matter by aerobic bacteria, and putrefaction, which is the slow oxidation of organic matter caused by anaerobic bacteria. Oxidation is also the joining of oxygen to a substance, the removal of hydrogen from a substance. It causes an increase of valence electrons due to a chemical reaction, but oxidation results in a loss of electrons during a chemical reaction. So I almost said anagram. That is not right. The acronym for oxidation would be OIL, OIL. Oxidation is the loss of electrons. So you have reduction as rig, reduction is gain. Oxidation is loss of electrons. And usually during chemical reactions between two inorganic compounds, reduction and oxidation take place simultaneously. An example of this could be like photosynthesis. I've uploaded a couple videos that'll show you this as well. It's called, when reduction and oxidation take place simultaneously, it's called a redox reaction. So that's just a brief explanation of that. Then I want to tell y'all about halogen elements. Y'all know about the halogens from microbiology. You know, they're group 7 on the periodic table. The most typical members are chlorine, bromine, iodine, and fluorine. Halogen elements form salts when chemically united with metal elements. They're classified as active nonmetal elements, and they've been assigned an oxidation number of -1. Remember when we talked about oxidation numbers, and when it's a positive oxidation number, that's how many valence electrons it's willing to give. And if there is a negative oxidation number, that's how many electrons they're able to receive. So halogens occur naturally as diatomic molecules like oxygen. Oxygen occurs naturally as a diatomic molecule as well, meaning that they don't naturally occur by themselves as an individual atom. There's usually two covalently bonded. Halogens are present in typical inorganic binary acid compounds. So inorganic binary means two acid compounds. Chlorine is probably the most familiar halogen element. It's often used as a bleaching agent. We know it in our swimming pools. Chlorine is a toxic, corrosive, greenish yellow gas that is irritating to the eyes and to the respiratory system. The most common compound of chlorine is sodium chloride, which is found in nature as rock salt and in seawater. We know it as table salt. The last element we'll talk about is the nitrogen, which is an element that's a component of the air we breathe and a constituent, meaning it occurs in many of our organic reactions, organic compounds as well. Nitrogen occurs in the air as a diatomic element. It's part of organic compounds such as amino acids, enzymes, and proteins, which we all know is in the cells of our body. It's very important to our bodily processes for homeostasis. Nitrogen-based organic compounds readily combine with formaldehyde to produce a decomposition-resistant substance called coagulate. Among the elements, nitrogen, it ranks 6th in cosmic abundance, meaning it's the 6th most abundant element in our universe. And the atmosphere of Earth consists of 75% by weight of nitrogen. Free nitrogen is found in meteorites and mineral springs. It's also found in the sun and in stars and nebulae. In the food industry, I can't pronounce things. In the food industry, nitrogen gas is employed to prevent spoilage of food through oxidation. It prevents mold. It can be an insect repellent. Liquid nitrogen is used for freeze drying and for refrigeration systems. So as you can see, nitrogen readily combines with formaldehyde as well to produce decomposition resistant substances, just like we don't want our food to spoil. You know, when we're preparing the human body, we use preservatives to halt or slow decay. So we use nitrogen. And that's just your quick lesson today. Make sure you read chapters 7 and 8. 7, I believe, is oxygen, and 8 is hydrogen, and just kind of help. This is just to help you kind of link what we do as embalmers to the foundations of chemistry, because chemistry is around us every day. So I hope that you all have a great week. Let me know if you have any questions. Bye.